So now we're moving into applications of these redox equations. So this wants to use our standard electrode potentials, and we want to calculate the standard cell potential. They've already balanced this equation for us. So what we need to first identify is what is oxidation and what is reduction in this scenario. So we're going to use oxidation as loss. So which one of these is losing electrons? And hopefully you said chromium. So oxidation would be 2 chromiums going to 2 Cr plus 3s, and well, you don't have to really do that. You can just, it's balanced, so you got to find what you're dealing with there. All right, reduction is going to be gaining, so this is going to be our lead plus 2 going to 2 electrons going to solid lead. Okay, so we have identified oxidation and reduction. Now we need to think about what's happening. So let's use our equation here for standard conditions. Here it has to be standard conditions or you can't use the table. So E cell, E0 cell equals cell potential of the cathode minus cell potential of the anode. All right, which one is which? Because that's going to be a difficult situation to determine. Oxidation always occurs at the anode. Reduction always occurs at the cathode. Okay, now we need our table of potentials. Okay, so let's find chromium. And here we have chromium going to solid. So again, don't reverse these, just leave it how it is. So negative 0.73. So I usually write this out here, negative 0.73 volts. And then we find lead. This is where things can get a little bit confusing, negative 0.13. And what we're doing here is, you said, but this is going in a different, this one's going in a different direction. Don't change the sign, just copy it from the table, and this equation takes care of what's happening. So our E cell can be our cathode, 0.13, V for volts, E for anode, 0.73 volts. So there we go. Now, most of you can probably do this in your head, but that's okay. So positive 0.6. Now, here I like to include the positive sign here. And remember, if you have a positive cell voltage, this is going to be going in a spontaneous direction.